magic. This girl's head seems to have come loose from her body. How can this be? Looking behind the scene, we can see that it's a very simple trick. The magician can make us see what he wants us to see by using a mirror and his knowledge of the properties of light. One of the properties of light is that it always travels in a straight line, unless something makes it change direction. It's easy to see light coming directly from a source to your eye. But trying to bend light around a corner doesn't work too well. Can we prove that light usually travels in a straight line? Try this experiment. With a ruler, make a straight line along the light beam. As long as the holes are lined up, the light passes through with no problem. If we move the holes away from the straight line, the light won't bend itself through the holes. But are there ways to change the direction of light? Let's pretend that these three balls are part of a light beam. As the balls travel down the board, they meet a smooth, straight surface. Notice that they all change direction the same way. No matter how many times we repeat this experiment, the balls bounce off in the same predictable direction. Now let's try the balls on a rough, uneven surface. They seem to go off in all directions. Every time we do the experiment, they behave differently. Will light behave the same way the balls did? Let's try bouncing a light beam off this straight-surfaced glass. The pattern of the light beam bounces off the glass and onto the wall in a regular, predictable way. If we substitute a crumpled, irregular surface for the smooth one, something different seems to happen. All we see is a fuzzy glow of light on the wall, not a predictable pattern. In general, we can say that smooth surfaces like this glass are good reflectors, and that irregular surfaces are poor reflectors. There is something else that is very predictable about reflected light. A mirror and a protractor will help us see what it is. By measuring the angle between the mirror and the light beam striking it, we notice a curious fact. This angle is identical to the angle between the mirror and the reflected light beam. No matter how we change the first angle, the second will always equal it. But there are other predictable properties of light. A mirror is normally what we think of when speaking of reflected surfaces. We can observe that our image seems to be standing behind the mirror. The reflecting rays of light are all coming back to us as if they were from the same size person behind the mirror. In fact, it appears to be the same distance from the mirror to the image as from us to the mirror. There is one thing different about our image in the mirror, however. Everything seems to be backwards. This is a very handy property of reflecting light. If we work it right, this secret code writing system will allow us to send messages that most people can't decode. But not all reflective surfaces create normal sizes and shapes. The two sides of this spoon seem to create completely different images. Why is this? A curved shape to a mirror seems to create this strange image. If we bend the mirror outwards, the image becomes very small. The curved surface makes it appear that the rays of light are coming from a smaller person. We call this kind of mirror a convex mirror. On the other hand, bending the mirror inward creates a different image. This concave mirror is concentrating the rays of light in front of the mirror. At some point, these rays meet in one spot. We call this spot the focal point. When the rays pass the focal point, the image is formed upside down. There is another way that light can change direction. If we shine a strong beam of light through this milky water, we can make a very interesting observation. Where the beam of light leaves the air and enters the water, it bends very noticeably. Think of the light beam as having a certain width. As the beam hits the water at an angle, one side slows down sooner. This causes the beam of light to bend toward the surface of the water. The opposite effect happens when the beam leaves the water and speeds up in the air. The side leaving first speeds up sooner and bends the light away from the surface of the water. This type of bending is called refraction. Even a very small drop of water can cause strange bendings of light. The refraction, or bending of light through this water drop, focuses the light into the center of the white spot. Notice that the area where the rays of light are no longer striking has gone black. Light passing back through our water drop also does a very unique thing. Very small print can suddenly become very large. Pieces of glass that refract light and change the size of images are called lenses. Lenses not only make things bigger and smaller, but they also make things clear or fuzzy. Using a lens, a light, and a screen, we can change the focus of a projected image. Move the lens closer to the light. Now move the screen so that the image is sharp again. Measure the distance between the light and the lens and screen. Try this several times. You will notice that as the lens gets closer to the light, you have to move the screen further away to keep the image focused. This property of lenses is very important to many people. For example, some of you may have had trouble seeing things close up, but you can see things far away. This means you are far-sighted. For the normal eye, images are sharply focused on the retina. However, if you are far-sighted, your retina is too close to your natural lens, and you'll have trouble focusing an image. Glasses or contacts made of convex lenses help concentrate the light and move the image forward so it focuses on the retina. Other people can see things close up, while things at a distance won't focus. These people are nearsighted. Again, the shape of the eye is the problem. Nearsighted people have retinas that are too far from their natural lenses, and images are hard to focus. Concave lenses that spread the light out will help focus the image onto the retina. magic. Maybe magicians can still play tricks on us, but now that we understand reflection and refraction, lenses and mirrors, now that we understand the properties of light, maybe things will be just a little bit clearer.